we will going to take up the animation on the gear trains, how the gear trains will transmit the motion from one gear to the other gear. And the assumption what we have made here is the module is 5 and the pressure angle is 20 degree. And one gear has got 48 teeth, the other one has got 24 teeth, and the third one which has got 36 teeth, and another one is 12 teeth. Having the gear thickness is 30 mm and the hole diameter is 20 mm. So to do that, so first I will go for new design and create a new fusion file, and now I will go for utilities, click on add-ins, come down to spur gear, click on this. So the pressure module is 5 and the number of teeth is 48. Then I want the gear thickness to be 30. Then I want the hole diameter is 20. Okay. Now D is equal to M into Z, where M is the module and the pitch circle diameter will be 48 into 5, which becomes 240. And now I will say OK. So this is the first gear which we are considering having gear teeth of 48. The next thing is, so I will go for adding, I will take this one as the first one. We will going to take this as blue and say I will close it. Again, I will go for the next one. So first I will go for select and you just click on this point, okay, and see the measurement of this. The diameter is 240, okay. And then if I want to check the thickness, you just click on this edge. So you're going to get the thickness as 30. Now we'll go for, similarly, we're going to create all other gears. I will just go for add-ins, go to script, click on spur gear. Now I will take 36 teeth and the rest of the things will going to remain the same. Okay, click on OK. Now we have second gear. So I'll go to select on this. I will take it out. Okay, go to appearance. I will select this as green. Okay, close it. Similarly, I want to go for 24 teeth. The next one is 24 teeth. I will go for add-ins, go to script, then come down to spur gear. Okay, take 24 teeth, which will be 120 diameter, and say the rest of the things is remain the same. Now again, I will go for select on this, select on this, and you drag this and you place it here. So again, go for paint. So you come down to red, click on this and say close. The next point is I will go for another gear, go to script, click on spur gear. So take 12 teeth. So pitch circle diameter will be 60 and say OK. Now you go to select on this. Okay. Select on this face, go to select on this and you take it out. Now you go for appearance, come down to yellow, click on this and say close it. So once you do that, now we will go for creating the base now, a plate on which it has to be mounted. So here, to do that, I will come down to this. First, I need to go to this particular component where I have exactly what I want. So here, I will just come down to this sketch, go to edit sketch. Now I want to create this particular plate. So you have a diameter 20. I will create that now. I will go to solid, click on sketch. Okay, click on the top plane. Okay, oh sorry, let it be like that. Okay, no issues. Now we will go for rectangle, select some arbitrary point and you drag this and keep it here. Then I will go for circle, select some arbitrary point and draw the circle. Check for the dimension, select this, give the dimension as 20. Okay, enter. Now I want to fix this. Go to constraint, go to fix and unfix. You have. This is a toggle switch wherein if it is fixed, it becomes unfixed. You just click on this so that that will not going to be moved. Okay. Then accept it. Then you come down to this. So I need to create one more circle here, which is of 210 from this. I will tell you what is the reason for 210 at the later stage. Now I will drag this, I'll go for select. I will select this and I will select this and I will keep it here. Okay. I will go for circle, select some arbitrary point and draw a circle and go to constraint, select equal, select between this circle and you select this circle. Now you go for dimension, select on this circle and you select on this circle. Give the dimension as 210. Then I want to come down to this, the next one, draw at 150 mm. So you come down to this. Similarly, you take one more circle here and go to constraint, select equal between this circle and this circle. Go to dimension between this and this. You give 150. Okay. Then again you come back to this and take 90. Go to circle, select this and go to constraint. Since it is equal, you select between this and this. Go to dimension, select between these two, then you will going to get 90. Okay. Now, if I try to move this, you can see how this exactly it is moving. Okay, because that portion is fixed. So that is the reason why it is not moving. So you can place it wherever you want. Okay, and this portion is being fixed. Now, I will go for finish sketch and go to 3D. And I will go for extrusion, select on this and give the dimension in the negative direction. You take whatever the dimension you want. I will say minus 25. Okay, join it or go to the new component. You select this on the new component and say okay. So I think this will going to be renamed as base. Let us say it as a base. Okay. Okay. Now I will going to give the appearance of this. It's a white paint. Okay. Take this and place it. Sorry. You just control Z. Okay. Go to appearance. Take this white paint and click here. Okay. Now I don't want this per gear to be grounded. I want this base to be grounded. You just remove, right click, unground from parent, this one, come down to base, make this as a ground to parent so that it will not going to be moved. Now the first thing is when you come down to this, okay, I'll go for finish sketch and the rest of the things will going to remain this. The first one is I want to space this first. So here I will go for select on this face. Okay. And now you take this out. Go to select position and take this out. Then go to join. Select this point with reference to this. I want to select this. So now it is rotating. So it is, that is the one which I want. I will just click on OK. Yes. Now the next point is the second one. What I want is I want that 3060 to be fixed. That is on the green color. You just go to select on this and move it out. Okay. Then go to joint. Now you select this portion with reference to this. Then you just click on this and you say OK. Now the reason for giving 120, that is basically because that is 210. I will go for inspect, go to measure distance between this point and this point is 210. The distance is where exactly that point is 210 mm. You can see here. So the reason behind this is if you take 48 teeth, you will get 240, so that is 120. If you take 36 teeth, 36 into 5 is how much? 180. So 120 plus 90 becomes 210. So that means if you go to the top view and if you see these two, the pitch circle diameter should match. If you select this and go to measure, then it will give you. So if you go, you just go to select this one, and if you go to inspect, that is measure, it says 90 mm radius. Similarly, if I select this, go to select and go to inspect, then it will give you 120 radius. 120 plus 90 is 210. So that is the reason why you are getting this. Okay. Now the next portion is I want to take this gear now. I will go for select on this face, and you take it out here. Now you come down to this, I'll go for joint, select on this face to this face. So it is going to the base of this naturally because the top surface I have selected, and now you just flip it and say OK. Now here this is also being rotated. Okay, fine. Similarly, I want to go to the last one. I'll go for joint, select on this with reference to fit, then take it on this. Then I want to flip this. All are rotational motion. Then you have fixed it. Now you come down to this position. Now here, the first thing what I need to do is I need to give a proper meshing between these two. So since the gateways are different, so you can be able to rotate this at different angle. So now, if you consider this relationship, and I come down to joint, if you select the first revolute, and if I try to animate this, so only this one will be rotating now. Okay, so it rotates in anti-clockwise direction. Similarly, if I want this, again I go for animate joint relationship, only the second one is rotating. Similarly, if you are going for revolute 3, and if you go for animate joint relationship, again that will be considered here. Similarly for revolution 4. The reason behind animate, go to revolution 4, right click, animate joint relationship. What is that? Yeah, this is the one. Okay. So the reason behind this, the dimensions, how much you have considered, as I explained to you, the same thing will be there for between these two. How to do that? I will come down to the top plane. Now you just take the position of this. Go to select this and this, measure. Okay. So that radius is 90. And similarly, if you consider this, that radius is 60. Okay. 60. 90 plus 60 is 150. Similarly, if you are considering between these two now, go to select this one, inspect 60 radius. Then if you select this one and give inspect 30. So 30 plus 60, again it becomes 90. So this is how, this is the relationship what we have considered. Now you're coming back to this. So I wanted to mesh so that there should not be any collision. So I will take this component and I will try to establish the link between these two. So you need to have this. So I go for, so I will take further inside so that you will have a proper meshing. So go to select. Now you have this now. So in this position, what I will do, I will capture this particular position. I will just capture this. Now I want to establish a motion link between these two. So to do that, I'll go for assembly, click on motion link, then select the joints. Which are all the joints I want? Revolute 1 and revolute 2. And then the motion here, if this rotates by 360, then the ratio between these two is 1.333. So I will say 360 into 1.333. I will take 360 into 1.3333. I will just establish the relationship. Now you can see both are rotating in the same direction. So this is also rotating in counterclockwise. This is also rotating in counterclockwise, but it should be in opposite direction. So I will just reverse the direction. So once you do that, this rotates in clockwise and this will be rotating in anti-clockwise. This is established the proper relation between the two gears. Okay, I will just stop this and I will say okay. Now you come back to this now. Now I need to establish the relationship between these two. So this is already fixed. Now I want to go for select. Now you drag this and you keep it outside so that there will not be any clash. So now I have selected this position. Go to capture position. Now I want to establish the relation between these two. So this is 36 and this is 24. 24, correct? This is 26 and 24. So that means if you want to have this between these two, then what is the relationship? 36 divided by 24. So 24 into 1.5. So that means, so here I will go for motion link. So here I will establish the motion link between what? Between the joints revolute 2, that is this one, and revolute 3, and that is this one. If this rotate this one revolute 2 by this, then this will be rotated by 360 into 1.5. Okay, 360 into 1.5. Then I will say animate relationship. Now you can see all the three are having a motion link between these two. I will just reverse the direction. So then what happens? This rotates in counterclockwise, this rotates in clockwise, and then this will also rotates in clockwise. Okay. If you don't reverse it, then this is rotates in clockwise, this is rotates in counterclockwise, this rotates in clockwise. Yes. Okay. Now I will go to fix this between these two. Again, I will just click on OK. Now I need to establish the relationship between these two. So all these things are meshing properly. Now you come down to this. And again, you just go to select this one and you take it between here and here. Okay. Check for this. Again, you select, go to select and establish. There is no contact prior to this. Okay. Both are having this position. Okay. Once you get this, see here. Go to select and I will take this here. Go to select and I will, okay, yes. Okay, I will keep it this, capture position. Now I want to establish the relation between 24 and 12. So that means if this rotates by 360, then it will rotate by 1.5. That is 2. So 720. In the sense that I will just go to assemble, establish the motion link between what? Between revolute 3 and revolute 4. Okay. If this I rotates by 180, then this will be rotated by 360. So just I'm giving the values. That is the ratio which will be considered. Again, I will just establish the animate joint. So now it is rotating in clockwise. This will be rotating in counterclockwise. Now if you say this rotates in clockwise, this rotates in anti-clockwise, this rotates in clockwise, and this rotates in the anti-clockwise direction. I will say okay. Now once you do that, so here this entire thing has been animated properly. Now this is going outside. So this is, you have a lot of space here. I will just go to this and click on edit sketch. Now I will try to move this and you keep it here outside. Then go to finish sketch. So now we have all the relationship which we have established. Okay. Then I will just go for animate relationship. Okay. Click on animate joint relationship now. So all these three rotate counterclockwise, this rotates clockwise, this rotates counterclockwise, and this rotates clockwise. So this is how you will be able to establish the motion relationship between the gears which are meshing with different number of teeth. This is how this gear train revolutions are going to takes place. That is, all are made out of spur gear having the same module but different uh, different teeth. One spur gear has got 48, the other spur gear has got 36, and this spur gear has got 24, and this spur gear has got 12. So this is how you will be able to establish the motion relationship between the different gears. Thank you.